Hi guys, welcome to section 6.3. Today we're going to specifically be looking at the sine function. So if you had y equals sine of x and you graphed it, you would get something called a sinusoidal function. So I'm going to explain a little bit of how our graph comes up to play, and then you're going to pause the video and I want you to spend some time actually graphing the sine function. So I want you to picture a wheel, like a water wheel, okay, in the water, and there's a nail on the wheel. And as the wheel spins, this nail is going to go down below the water and it's going to come back up above the water and then back down and back up, okay? So if I were to take this wheel and simplify it, you could imagine that the water level would be my x-axis. The center of the wheel would be right here, and you could imagine the y-axis going up and down as well. So this would be the origin of our Cartesian plane. And then we want this wheel, we're going to force it to have a radius of 1. And that's just going to make our lives a little bit more simple when we're graphing. So we have this nail on the wheel, and we're going to make a triangle from this nail. So there's the center of the wheel. We've got the nail, we've connected them, and then I'm going to drop a line down to create a 90-degree angle and a right angle triangle. Because the radius of the wheel is 1, our hypotenuse of the triangle is 1. We don't know what this angle is, it's going to change, but the height is really what we're interested in, okay? And the height we're just going to call h for now. So as this wheel changes locations, right? So you can follow along with the pen. If it was up here, the height would be different. Versus if it was down here, the height above the water would be much lower than it is where we've got our triangle. And as it goes around, you'll notice that the height to wherever the x-axis is or the water level is different. And yes, the nail can travel below the water, and we would have different heights below the water down here. Okay, so I want you to keep this triangle in mind. The first thing we're going to do is determine how high this nail is at 0 degrees, and then 30 and 60, and you're going to finish up the chart. So if I have, the 0 degree one's kind of weird, but if we had 0 degrees, so now we're going to imagine this line, the nail is right here. It's right here on the surface of the water. It is not above the surface at all. So if you were to plug in sine of 0, you would actually get an answer of 0. Okay, and I know that one's the weird one. Just bear with it for a second. And the other ones are a little easier to explain. Okay. All right. So now I want you to picture 30 degrees. So let's pretend that this x is actually 30 degrees. Okay. So we've got my nail right here on the wheel. I've connected a line from the center. You can think of it like a spoke of the wheel, or maybe you've attached a string just to see it. And it's got a length of 1. So my hypotenuse of this triangle is 1. My angle is 30. I need to figure out how high it is. If you go back to your trig ratios and you think about SOHCAHTOA, this is the opposite to the angle, and this is the hypotenuse. So opposite and hypotenuse deal with your sine ratio. So if you remember sine, and I'm just going to shortcut this, of your angle, we'll say sine of theta equals the opposite over the hypotenuse. In this example, sine of 30 is the opposite. In this case, I've labeled it h for height, over the hypotenuse. And my hypotenuse is 1. So, and in our scenarios, it's always going to be 1, which is why I wanted you to have that radius of 1. So if I want to know what the height is, I just have to find sine of 30. So you can take your calculators and plug in sine 30. When you do, you should get an answer of 0.5. If you're not getting 0.5, please make sure your calculator is in degree mode. Okay? So in theory, that's what's happening, is we are measuring the height of this nail as we go around. What I would like you to do is take your calculators and plug in the sine of each one of these degrees, right? Because we've got, now we go all the way down to 360 degrees. So this is 30. If I go all the way up here, this would be 90 degrees. Going this way, from my starting point, that would be 180 degrees. 270 would be down at the bottom. You've traveled all the way around. And then 360 would be from here all the way around back to the starting point. Okay, that's 360. So you are going to calculate sine of 0, which is 0, sine of 30, which is 0.5, sine of 60, if you plug it in, you should get 0.86, 0.866. Try and keep a few decimals. I know it's not going to be perfect. And then at 90, sine of 90 is 1. You're going to continue, okay? Once you have completed your table of values, I've given you a graph here. You are going to graph these values. So think about this like an ordered pair. These are your X values. These are your Y values. It's going to be very long, but not very high. So 0, 0, I have a point here. 30.5. 30, well, this is 1, 0.5 is right in the middle. Now, 60 and 0.866. Well, if here's 60, 0.866 is not really in the middle. It's actually a little bit higher. Remember, if you round, that's close to 0.9, so it'll be pretty high, but it's not touching the number 1 yet. And then at 90, it's 1, okay? You're going to continue, and you are going to get a beautiful curve. Something's going to happen here, and that's what I would like you to do. I'm going to pause my video. I want you to pause my video. And I'm going to put the rest of the points in, and hopefully your graph will match. I only want you to continue after you have graphed, okay? So take a second and pause the video now. Okay, I hope you've had a chance to fill in the rest of the values. You should get a graph that looks like this. I've just put the rest of the dots in. And when you connect it, and I apologize with the pen tool that I'm using, I'm trying to go nice and slow to make it neat. There you go. You should get a graph that looks like this. And this cycle will repeat because the nail will go up and down over and over, and you can have angles and degrees that are over 360, and you can go in negative directions. So you will get this pattern over and over again. Your sine function, which is what you calculated, produces a periodic function. All right, so keep that in mind. We're going to explore some other parts to your sine function. All right. So yesterday or last class, I mentioned that you had a something called an equation of the axis, and that was the middle point between the peak and the trough, the highest and the lowest point. Sometimes we'll refer to the peak as the maximum. The maximum is the highest value where your peak is, and the minimum is the lowest value where your trough is. So we have a maximum and we have a minimum. The equation of the axis is the point or the line directly in between my highest and lowest points. So if I take my maximum value, add it to my minimum value and divide by 2, I'll get my equation of the axis. So you're basically taking the average of the highest and lowest points to get the middle value. And that is this line right here, okay? A new definition for you that you're going to learn today is called the amplitude. And the amplitude, so let me just do this in a different color so you can see how pretty these things turn out to be. So if my equation of the axis is right there, my amplitude is the height from this equation to my maximum or to the peak. Okay, so this is the amplitude right here. Okay, they drew the arrow at the side, it doesn't matter. Okay, so it's from the equation to the highest point that you have. Your sine function is what we are graphing. That's this guy right here. And you can measure degrees in you can measure angles in terms of degrees or radians. For our purposes, everything we do will be in degrees. Okay. So consider your sine function. This is an example of the sine function that we have up at the top. So if you take a look, the amplitude of ours, and if you go back to the one we graphed on the previous slide, the amplitude is 1, okay? So make sure you're looking at your graph. Oh, perfect, there's one below. Make sure you're looking at your graph or a graph as we answer these. Now, the period was the distance of the cycle. So if we take a look, it starts here and it comes all the way and stops at 360 degrees. After that, the pattern would repeat. So our period is 360 degrees. Okay. The axis is defined by the equation x equals 0 because it happens, oh, sorry, y equals 0. It happens when the y value is 0. Okay. Our domain, well, because this pattern repeats over and over and over, if you go back to domain and range from earlier in the course, the domain are all of the x values and the range would be all of the y values. So domain, x can be any real number. Hopefully you remember drawing all these funny symbols on the board. Okay, so XER means x is an element of the real number system. And my range, again, my range can be a small number down to -1 and any number in between up until +1. So -1 to +1, but it can be any of those values. So here, y is also an element of the real number system. Here we go. However, we have to put the such that y must be greater than or equal to -1, but less than or equal to +1. And we're supposed to be putting our brace brackets or our curly brackets around our domain and range, okay? So we've got domain, our range, our amplitude, the period, and the equation of the axis. Now, you need to be able to draw these and you need to know some of the main points because we are going to be curve sketching these later. I do not want you to memorize 360 degrees worth of points. That's too many. It is a curve, it goes up, it goes down. You're gonna remember 5 points. You're gonna remember this one, the one at 90, the one at 180, and the one at 270 and 360. Now I know I don't have the values here. We're gonna put them down in a second. Here we go. They are also seen on this graph here. So you have to memorize the point 0, 0. You must know the point 90 degrees and +1. You must memorize the point 180 and 0. That's this guy, okay? You have to remember 270 and -1. That's this guy. And 360 and 0, which is this guy. So these go up by 90 degrees. If you think about that wheel again, it's the x-axis, the y-axis, the x-axis, and the -y. So we go up by 90 degrees each time. So these increase by 90. And these ones, right, it's a periodic function. So it's a pattern that repeats 0, 0, 1, 0, -1, 0. Okay, so you have to have these memorized and we're going to use those to curve sketch. All right, I think that is it. There's just one more example where we can pick up some of our values off of a graph, and then we are done for today. All right, so word problem or word question. Sarah is sitting in an inner tube of a wave pool. The water below her, obviously if you're in a wave pool, it goes up and down. So this is a periodic function of her height above the ground level of the pool, okay? So it's the height of the water below her. So if we take a look at this, the amplitude, now remember the amplitude was the max added to the min divided by 2. It's this middle point. So just by looking at it, I can see that the amplitude, oh, sorry, I'm going the equation of the axis. Let's talk equation of the axis first. The equation of the axis is the high point plus the low point divided by 2. That'll give us the line right in the middle. By looking at the graph, you can see that it's at 2. If you wanted to confirm using algebra, you'll notice that every 2 squares is 0.4. So I'm going up by 0.2. So this up here, this should be 2.4. So if I take 2.4 and I add it to 1.6 and divide by 2, okay, 2.4 plus 1.6 is 4. 4 divided by 2 is 2. So you do get this number for your equation of the axis. Okay, that puts a nice line, oh good, it's already green, right across. Okay, so that's our equation of the axis. Now the amplitude is the distance from the top, from any of your peaks, to the equation of the axis. I've gone up 2 squares, which is 0.4 units. Okay, I guess we're talking meters, so 0.4 meters. So the amplitude is 0.4. The period is the distance of a cycle. So if you take a look, we start here, we go up, down, and when we get back here, then the pattern starts to repeat. So the period is the distance from the starting point to the ending point of my pattern before it repeats. So the distance from here to here is 3. I've got 3 seconds. There we go, 3 seconds. Domain would be any real number as long as she stays into the pool. So XER, and then the range. There we go. And the range, we are looking at the y values. The lowest one would be 1.6. The highest one would be 2.4. So remember, y can be any number because it can be any of the values in between. It's continuous, such that y must be greater than or equal to 1.6, but less than or equal to 2.4. Okay? Don't forget your brace brackets. And that's it. So all you're doing today is just graphing your sine function, getting used to what it looks like, and identifying this time amplitude and equation of the axis. Okay, guys, great job today. We'll see you for your next lesson.